Welcome to Maths and Science by IITian channel. In this lecture today, we will be discussing about roots of unity, in which we will be concentrating on number of primitive roots, that is, for a particular nth root, number of primitive 276th roots of unity. This we will be discussing. This requires knowledge about Euler-Totient theorem. Euler-Totient theorem in number theory. In addition to that, we require knowledge in complex numbers and roots of unity, and z to the power of 276, where z is a complex number, is equal to 1. Then how many number of primitive 276th roots are there in the given equation? Answer is certainly not 276. It is other than 276, because we are talking about the primitive roots. And primitive root means if this number is n, then 0 less than n if this number is n and z to the power of k should not be equal to 1 when 0 is less than k less than n. This is the rule of the primitive nth roots of unity. Here n I have taken it as 276. That means z to the power of 276 is equal to 1. Will have 276 total roots, but all are not primitive roots. Primitive roots will be lesser than the total number of roots. That I will explain what is the primitive root with a small example. Then we will solve this problem using the Euler-Totient theorem. How to do it? Let us do it one by one. Let us understand. Let us say z is equal to 276. Z to the power of 276 is equal to 1. That implies 276th roots of unity. For example, to understand this, let us take a small example and try to understand. Solution. Then what we require here? Number of primitive 276th roots of unity. This is what is required. Now, let us take a simple example and try. When you take a small example, instead of 276, you will understand very easily. Let us take Example, z to the power of 4 is equal to 1. Let us say. That means there are 4 roots for unity. If z to the power of 276 is equal to 1 means there are 276 roots for unity we are considering. Here z to the power of 4 is equal to 1 means we are considering 4 roots of unity. What are those 4 roots? I have already explained in my lectures in complex numbers. Please refer to those lectures. Lectures on complex plane and complex numbers. There is a lecture called Roots of Unity. Lecture is Roots of Unity. You please refer to that lecture and try to understand the roots of unity. Here, z to the power of 4 is equal to 1. That implies there are 4 roots. 4 roots of unity exist. What are those 4 roots? Z can be I, Z can be minus I, Z can be 1, Z can be minus 1. Do you agree? These are the 4 roots of unity. It is in the complex plane. This example is very useful for basic understanding of the concepts, and this question is also very useful for JEE Mathematics and also for Maths Olympiad. Now, if z is equal to 1, z is equal to I, z square is equal to I square, that is equal to minus 1, z cube is equal to minus 1 into I, that is equal to minus I, z to the power of 4 is equal to minus 1 whole square, that is equal to 1. What are the roots? 4 roots. If z is equal to I, z square is equal to so and so, z cube is equal to so and so, z to the power of 4 is equal to so and so. That means the roots are I, minus 1, minus I and plus 1. These are the 4 roots. Now, what is the condition for finding the primitive? Z to the power of k is not equal to 1 when 0 is less than k is less than n. Here what is n? N is equal to 4. K is less than 4 means k is equal to 1, 2, 3. When k is equal to 1, what is the value? For k is equal to 1, z to the power of 1, whatever given equation becomes value becomes 1. When k is equal to 2, the value is minus 1 from this. When k is equal to 3, the value is minus 1. None of these values, please try to understand this logic. I minus 1 is minus 1 and it is minus I. Sorry, it is minus I. 1 minus 1 minus are not equal to 1. They are other than 1. Then the condition of primitive roots is fulfilled. For n is equal to 4, k less than n, z to the power of k is not equal to 1. Are you able to follow? When z to the power of n is equal to 1, then for some k, 0 less than k less than n, if z to the power of k is not equal to 1, then that particular root is primitive. Are you able to follow? This is the most important statement. Please try to understand this. I will redo the problem again if you want. I will redo. When the total roots of z to the power of 1 are 1, I, minus 1 and minus I, let us say. Because these are roots, these are z values. Z is equal to 1, z to the power of 4 is equal to 1. Z is equal to I, z to the power of 4 is equal to 1. Z is equal to minus 1, z to the power of 4 is equal to 1. Z is equal to minus I, z to the power of 4 is equal to 1. These are the roots of unity. Now, out of which, that means k is equal to n is equal to, first write n is equal to 4, k is less than 4, n integer less than 4. Now, that means 0 is less than k is less than n, implies 0 is less than k less than 4. That means k takes the value 1, 2, 3. Are you able to follow? When k takes the value of 1, 2, 3 and here I will work out one by one. I have worked out when the root is I have already worked out. What are the roots? We know the basic roots are 1, I, minus 1, minus I. Again I will do for the sake of you, root is equal to 1, let us say. Let us consider this. What is z to the power of k is equal to what? For k is equal to 1, 2, 3. For k, z is equal to 1 is the root. First root, let us say. Then 1 to the power of 1. 1 to the power of 1, that is equal to 1. 1 to the power of 2 is equal to 1. 1 to the power of 3 is equal to 1. and 1 to the power of 4 is equal to 1. When you consider these 3 only, when k is equal to 1, 2, 3, this value is equal to 1. But what should be the condition? Z to the power of k should not be equal to 1. That is the condition for primitive root. That means 1 is not primitive root. Are you able to understand? How to find the primitive root? Simpler manner I am making you understand. Now, second case is, what is the other root? Z is equal to I. We will do it again. Z is equal to I. This is the second root. Second root. Z is equal to 1 was the first root. For this, k is equal to 1, 2, 3 and we have to find out zk, z to the power of k. Z to the power of k for 1, 2, 3 is equal to k. That implies z to the power of 1 is equal to I to the power of 1, that is I. Z to the power of 2 is equal to I to the power of 2, that is minus 1. Z to the power of 3 is equal to I to the power of 3, that is minus I. Z to the power of 4 is equal to I to the power of 4, that is equal to 1. Now, when you consider only up to k is equal to 3, all these 3 are not equal to 1. That implies z to the power of n is equal to 1, that fourth power. But z to the power of k is not equal to 1 when k is equal to 1, 2, 3. When n is equal to 4. That means it is a primitive root. I is a primitive root. This is the definition of the primitive root. Now, third case let us see. What is the third case? Z to the power of 3 is equal to, what is that third root? Third root is minus 1. Minus 1. Then, what are the values of z to the power of k for 1, 2, 3? Z to the power of 1 is equal to minus 1 to the power of 1 is equal to minus 1. Z to the power of 2 is equal to minus 1 square is equal to 1. Z to the power of 3 is equal to minus 1 to the power of 3, that is equal to minus 1. Z to the power of 4 is equal to minus 1 to the power of 4 is equal to 1. Here if you say one value is exactly equal to 1. Hence, what is the conclusion? Z cube is equal to minus 1 is not a primitive root. As z to the power of 2 is equal to 1. But as per primitive root, z to the power of k for 1, 2, 3 should not be equal to 1. Hence, this is not a primitive root. We have got till now only one primitive root, that is I. Now let us see what happens when in case of case 4. Z is equal to minus I. What happens to z to the power of k? Z to the power of 1 is equal to minus I. Z to the power of 2 is equal to minus I whole square, that is I square minus 1. Z to the power of 3 is equal to minus I into minus I square z into z, minus into minus plus I square is equal to minus 1. Now z to the z cube. What is the value of z cube? This is I. Why it is I? The reason being z into z square. Z into z square is z cube. Z is minus I and z square is minus 1. That is equal to plus I. And z to the power of 4 is minus I to the power of 4 is equal to 1. Now you see, all these three are not equal to 1. Means z to the power of k is not equal to 1 for 0 less than k less than 4. And at the same time, z to the power of 4 is equal to 1. Means z to the power of n is equal to 1. It is a root, but it's a primitive root. Are you able to understand? Hence, when you take a small case like z to the power of 4 is equal to 1, it gives 4 total roots. These are all total roots. 1 plus I minus I minus 1. These are the total number of roots. Whereas primitive roots are I and minus I. That means primitive roots are always lesser than the total number of roots. Hence, in the first page itself, I have shown answer is not equal to 276. When you talk about the primitive roots in number less than number of primitive roots is less than number of total roots. This you please remember. In an examination, if it is asked, then without any doubt you should be able to recollect this example. See the solution of this example 1 or 2 times if you could not get it. This is the concept. Now, if n is equal to 276, is it possible for finding the each and every root and calculating it to find the primitive roots, to find all the primitive roots? For larger n is equal to 276, that means 0 is less than k is less than 276. That means k up to 275 to be calculated. Is it possible? For each and every root, total roots are 276. What are the primitive roots? What is the number of primitive roots? That is the question. Can we go on doing for each and every root the above exercise and find out number of primitive roots? It's very difficult. For that, there is a theorem called Euler Totient formula. Please remember this formula. Euler Totient formula in number theory. What Euler Totient formula says? the number of primitive roots is equal to represented by phi n, where n is the total number of roots, phi n is the number of primitive roots, n is total number of roots for z to the power of n. Number of primitive roots is phi n. There is a relation between phi n and n from Euler-Totient formula, which states that phi n is equal to, please remember this, phi n is equal to n into one minus one by pi p1 into 1 minus 1 by p2, 1 minus 1 by p3 and so on. Where P1, P2, P3 and so on are the prime factors of the given n. Distinct prime factors rather. Each and every number should be distinct. If 2 comes 2 times, you should take only 1 time, because it is distinct prime factors. Now, 276, how you will write? 276 is equal to factors of 276. Please do factors. It is divided by 2. 2 into 276 by 2. What is its value? 138. That is equal to 2 into 2 into 138 by 2. It is divisible by 2 again. 69. 69 is divisible by 3. 23. 2 into 2 into 3 into 23. Do you agree? These are the prime factors of 276. And in this, what are the distinct prime factors? 2 and 2 are same. Hence, we will take 2 only once. And what is the distinct? 3 is a distinct number other than 2. And what is 23? It is distinct other than 2 and 3. That is 23. That means how many are there? 3. Distinct prime factors. Please remember that word. Distinct prime factors. Then, as per Euler-Totient formula, phi n, the number of primitive roots is equal to n into 1 minus 1 by p1, 1 minus 1 by p2, 1 minus 1 by p3. In this only 3 prime numbers are there. I am writing up to p3 only. You can write any number if you have more as per the given n. That implies phi n is equal to n is 276 into 1 minus 1 by 2, 1 minus 1 by 3, 1 minus 1 by 23. You please find out 276 into 1 minus 1 by 2 is 1 by 2, 1 minus 1 by 3 is 2 by 3, and this number is 22 by 23. Do you agree? That means the primitive prime numbers phi n is equal to 276 into 1 by 2 into 2 by 3 into 22 by 23. Just find out this number. This number is 88. That means total roots r is equal to 276, whereas primitive roots r is 88. 88 is the answer. This is the difference between a primitive root and a total root. For the example which I have done previously for z to the power of 4 is equal to 1, I will just draw unit circle and show how primitive numbers and how regular roots are shown. This is a very important topic. It is a unit circle. You all may be knowing. This is x-axis is real, y-axis is imaginary number. And how do you show z is equal to I? Z is equal to plus I is here. Here it is I. Z is equal to minus I is here. Z is equal to plus 1 is here. Plus 1. Z is equal to minus 1 is here. Minus 1, minus I, plus 1 I. All these four are total roots. What are the primitive roots? Primitive roots are only these two. This one is the primitive root. This one is the primitive root. Similarly, if there is a circle with 100 roots, unit circle, z to the power of 100 is equal to 1. Let us say 100 roots are there. Then the 100 roots will be like this. It's not to scale. I am just putting it for your understanding. The dots, these may not be 100 also, just as an example. Now, these are the regular roots. In red color, these are the primitive roots. That means the regular roots overshine the primitive roots. This way, this is primitive. This is primitive. This is from the number theory, Euler, Totient formula that gives number of roots, primitive roots rather, and complex numbers. That complex analysis which I have started this maths and science lectures. That complex numbers, complex analysis is going to give the total roots. Total roots in green. Primitive roots are in red. This is the concept behind the primitive roots, total number of roots, and roots of unity. All the roots of unity, they lie on the same unit circle. They lie on the unit circle circumference. If it is 4 roots like this, it will be each quadrant 1 root. If it is 100 roots, on the same circumference 100 parts will be done, that unit circle. That means ultimately, if z is equal to z to the power of n is equal to 1, then primitive roots are such that z to the power of k is not equal to 1 when 0 is less than k is less than n. This is the principle which we have used and found out the primitive roots. Because it is not possible to find out each and every primitive root and write and understand it and calculate it, Totient has come up with a Totient formula, Euler Totient formula. Euler Totient formula that says number of, directly we will write phi n is equal to n into 1 minus 1 by p1, 1 minus 1 by p2, 1 minus 1 by p3 up to the number of primitive roots are there. This is what is the number of, not primitive roots, rather number of primes, distinct primes, where the factors of n having distinct primes as them, as p1, p2, p3, etc. The distinct prime divisors of n, distinct prime divisors of n. This is what is about to find the primitive roots when z to the power of n, any number is given. We can find out the number of primitive roots. With this, I want to conclude this lecture, and if there is a value addition to your knowledge because of this lecture regarding complex numbers, roots of unity, complex numbers, roots of unity, primitive roots of unity, and Euler Totient formula. If you have got any value addition to your knowledge regarding these, please share my channel and videos and subscribe to my channel. Maths and Science by IITian. Thank you for listening to me. Thank you for viewing my lecture. Best of luck to everybody. Thank you.